Another important thing is boats and streams. Boats and streams is also a very useful concept, very important concept. How does boats and streams work? Boats and streams basically assume that if you're going in a stream, suppose this is the stream, and suppose the river is flowing in one direction. The speed of the river also is assumed. Let us assume that the speed of the river is s meter per second. Now, what we assume in this is that the boat also has a separate speed, which will be independent of the speed of the river. That is, if the river was not flowing in still water, let us assume that the speed of the boat is say b meter per second. This is the direction of the river. So now if the river and the boat, both of them are going in the same direction, that is called downstream. What is assumed is that the speed of the river helps the speed of the boat, and overall with respect to the ground, the speed of the boat will become b plus s meter per second. But suppose the boat is going in the opposite direction of the river. That is, suppose this is A and this is B. After going to B, suppose the boat is coming back to A. The river is going in one direction. The boat is coming in the opposite direction. So now the river is actually blocking the boat. So the speed of the boat when it is traveling in the opposite direction is called the speed upstream. This will be b minus s seconds. B minus s meter per second. This is basically something that is understood as far as CAT is concerned. This, when somebody says downstream, it is the river of the speed of the river plus the speed of the boat. When somebody says upstream, it is speed of the boat minus speed of the river. A boat goes 30 kilometers upstream and 44 kilometers downstream in 10 hours. In 13 hours, it can go 40 kilometers upstream and 55 kilometers downstream. The speed of the boat is. So let us assume that speed of the boat upstream is u. What is u? If you assume that speed of the boat is b and speed of the stream is s, u is equal to b minus s. And speed of the boat downstream is d, and d will be equal to b plus s. We are given two equations, we will be able to find out u and d. It travels 30 kilometers upstream. So what is the time taken? The time taken will be 30 by u, distance divided by speed, plus 44 kilometers downstream. So that is plus 44 divided by d. This we are told is equal to 10 hours. This is the total time that is taken. Similarly, in 13 hours, it can go 40 kilometers upstream. 40 kilometers upstream is 40 divided by u. And how much will it go downstream? It will go 55 kilometers downstream. Plus 55 by d. And how much time is it taking? It is taking 13 hours. So we have to calculate u and d. We will multiply this equation with 4 and this equation with 3. Because then this is 30 by u and this is 40 by u. So both of them will become equal. If you are multiplying the first equation with 4, we are going to get 120 by u plus 44 into 4 is 176 by d is equal to 40. If you are multiplying the second equation with 3, we are getting again 120 by u plus 165 by d is equal to 39. If you subtract one equation from the other, we are going to get 11 by d is equal to 1, or the speed downstream is 11 kilometers per hour. We can substitute it in any one of the two equations. Suppose we are substituting it in this equation. This will be 40 by u plus 5, because 55 by d, d is 11, is equal to 13. 40 by u is equal to 8, or u is equal to 5 kilometers per hour. So the speed upstream is 5 kilometers per hour, speed downstream is 11 kilometers per hour, or b plus s is 11, b minus s is 5. So the speed of the stream, which is what we are required to calculate, if you subtract one from the other, 2s is equal to 6, or the value of s is 3 kilometers per hour. So the answer for this question is option A, which is 3 kilometers per hour.